So we will see three different ways to design a QCM transmitter. QCM transmitter means there is one in phase carrier and another one is a quadrature phase carrier. And at the I branch, the in phase part of the constellation goes, and Q part or the Q portion, the Q part of the constellation goes, and this is the bit to constellation mapper. For example, if you are following 8 PSK and 000 is mapped to this point, in phase this component, the value of this component will be transmitted through I part and Q channel. This is also known as channel, I channel, Q channel. And then we subtract I channel information with the Q channel and then we transmit it. So this is the transmitted signal. There is one more way you will find in books. He will normalize the energy of this signal. So if T is the duration of the signal, what is the value of T if you are using M Array constellation? If the constellation is M Array and bit duration is TB, the time duration of both phase and quadrature phase will be log 2m of TB. So in general we take it as T. So the energy of A cos 2 pi FCT between from 0 to T, so we will just normalize it with the root of E so that this signal has unit energy. Similarly, we also normalize this with the energy. Here this is I2Q, or sorry, bit to constellation mapper. So this part, if we represent it by phi1t and this phi2t, phi1t can be written as A cos 2 pi FCT divided by square root of energy of such signal is A square T by 2. Therefore, you can write root 2 by T cos of 2 pi FCT so effectively that QCM transmitter, it is bit to constellation mapper again. Phi 2t. So one more point we do, we add negative here, this minus we sign included here. So phi 2t is minus of phi 2t is minus a sine of 2 pi FCT square root of E, which is minus a sine of 2 pi FCT a square T by 2. So in few bits you will find QCM like this. One more way we can represent this type of transmitter, which is both in I channel and Q channel. If you remember, xt a cos 2 pi fct minus, so in this here, in phase part of the constellation point goes from here, quadrature part of the constellation point is transmitted. So you can write it like this. And I leave it to the readers to prove this. Just you can easily go check whether this step is true or not. So this is some complex number. We represent it by AC, A superscript C. So in many places you will find that you can also represent, or this is the schematic of QCM transmitter, which you can also, so this is AC, this is bits e to the power j 2 pi fct, take real part, or you can also think that this A is some power amplifier gain. So whenever you pass, square of this part get multiplied in this. So you can think that this is also, in books you will also find this is also a QCM transmitter. And this type of design is helpful in analyzing the digital communication setups.